This lesson is going to take equilibrium to the next level. We will, instead of just having one force on each side, we're going to have three forces. For this particular scenario, you can see that this plank of wood, although it's got uniform distribution of mass, has not been placed in the center. With the center of mass, which is bang on in the middle there, the center of mass is not above the pivot point. So that generates a force there, and because there's a distance from that force to the center of mass, which I can mark in here, that there is the distance to we'll call this a plank, so we'll call it distance to plank, to subscript P for plank. All right, there's also on the system, there's a person down here, and there's another person over here. Alright, but it's all in equilibrium. This one here will have to be generating a force, like that. And this one over here will also be generating a force. So you can see that we've got, now we're in the situation where we've got three forces. Alright, because it's equilibrium, it's true that the torques that are turning this way are equal to the torques that are turning clockwise. Okay, that's a true statement, just as what we had before. We'll call this one boy, and this one girl. All right, so we've got the anti-clockwise torques here generated by the boy. So same as what we did last time, where torque is equal to force times distance. So we get hold of the boys. So we've got force of boy times distance to boy. The distance to the boy will be measured from there to there. So that's distance of boy is going to be equal to the torque. So we've got here the torque of the plank, which is force of plank times distance to plank, plus, because that's trying to make it turn this way, the plank is, but so is the girl. So we've got to add on the force of the girl times the distance to the girl. And we'll have a measurement from there will be given. But the actual distance that we use for the girl is going to be that distance in there. So that's distance to girl. Alright, so you can see I've added the figures in. Our goal for this particular question is we're going to try and find the mass of the girl. That's what we're trying to work out. Alright, so we've got our first line of working. Next line of working, we need to expand it out. I'll just point out that I like to keep my equal signs directly underneath the pivot, and that helps you realize that all the things on this side are trying to make it turn clockwise. The things on this side are trying to make it turn anti-clockwise. So our next stage is we bring in the formula F is equal to mass times gravity. So instead of FB, we can substitute in mass of the boy times gravity times distance to boy. On this side, instead of FP, we can put in mass of the plank times gravity times the distance to the plank, plus mass of girl, which is what we're trying to work out, times gravity times the distance to the girl. Okay, you'll see that this year is a lot of work, but in your exam at the end of the year, you will only have to do it once. So it's going to be a case of do it once and do it very carefully and do it right. Okay, if you try and look at it in the SciPad answers, it's not very easy to follow, so I recommend this way, even though it takes up a lot of paper. So we've got the mass of the boy, so we put in 70 there, times 9.81, times the distance to the boy, which is all measurements taken from the pivot, so it's times 1.2. Over on this side, we've got the mass of the plank, which is 15 kgs, times by 9.81, times by the distance of the plank, so measured from the pivot, and that's 1.4. need to put that into a bracket, and then we go plus the mass of the girl, which stays as mass of girl, times 9.81. And here goes our challenge. This will be done commonly to you, where they give you the 2.6. That is not the correct distance. To find the distance to the girl, you've got to find how far is the girl from the pivot, not how far the girl is from the center of mass of the plank. So you've got to go that number plus that number, and that gives you distance to girl equaling 4 meters. So we put times 4. Alright, and that's the next line of working. Now we've got to get this 206 over to this side. It follows the change side, change sign, so it becomes negative. 206 is equal to mg, which is the mass of the girl, times 39.2. Alright, and our last step is to get the 39.2 from that side. We need to divide both sides by 39.2. On this side we get to cancel them, so that makes mg, the mass of the girl, the subject, and it works out that the mass of the girl is 15.76, which for our accuracy will round to the mass of the girl is 16 kilograms. So I could tell right from the start that because on this side you've got a longer distance to the girl, and also you've got the torque generated by the plank, that's telling me that the girl must not be very heavy in order to cancel out the mass of the boy. So 16 kgs looks a very good answer.